We're now going to talk about a new concept called function composition, or how to find a composite function. Okay, so as you can see here, a composite function can change a two-step process into a one-step process. The input of the second function depends on the output of the first function. So what does that mean? Well, let's think back to when we thought of functions like machines, okay? So let's say we have this function g. So I'm going to call it little g. So remember, for the function, we put in an x value, and we get out a y value, which we can also call g of x. Okay. Now, what would happen if we wanted to connect up a new machine right after that machine? We'll call this one f. And we wanted to take the output from g and put it right into f. Okay, so normally here we're putting in a number, we're getting a number out. We're now going to put the number we got out into this new machine. And it's going to give us out a new y, or we would say it was f of whatever value we put in. And the value we put in was this g of x, so it's f of g of x. Okay, now what we want to do now is think of this as one machine instead of two machines we've put together. So here, we're going to call this new machine f composed with g. Okay, so this little circle means composed. So this function is called f composed with g. So what we're saying is we're putting in an x value. It's first going to go into g, then it will go into f. And we get out what's called f composed with g of x, just like we did up here. Okay, so we'll talk a little bit about how to find this algebraically, but that's the main idea. You're putting in a value and you're really doing it to two functions. Okay, so let's go ahead and see how we do this algebraically. So here it says, given f of x equals 2x plus 1 and g of x equals x squared plus 4, find f composed with g of x. Now, what this means is we want to find f of g of x, meaning we want to plug in g for every x in f of x. Okay, we're putting all of g into f. All of g into f. So you're always putting the second one into the first one, okay? Think of, you're starting with the one that's closest to the x and putting it into the one that's furthest away. So how I kind of like to think about this, if we're doing f composed with g, start with writing f out, the first one, with just a set of parentheses wherever there's an x. Okay, so our f was 2x plus 1. I did 2, set of parentheses with a space, plus 1. Now we want to plug g of x anywhere we have an x, so we're going to take all of g of x and plug it into that set of parentheses. So we'd have 2 times x squared minus 4 plus 1. Now, we do want to simplify this if we can. We're not going to solve or anything. It's going to have x in it. But let's look and see how we could simplify. So the first thing we could do is distribute this 2 to the x squared and the 4. So we'd have 2x squared minus 8 plus 1. And then our last step, we can combine like terms, 2x squared minus 7. So I just combined the negative 8 and the plus 1. So here what we're saying is that f composed with g of x, this is a function, and it's equal to 2x squared minus 7. Okay, so the next part asks for f composed with g of 7. Well, we already found that f composed with g of x was this function, 2x squared minus 7. And now this just means we're going to plug 7 in for x. So f composed with g of 7 will be 2 times 7 squared minus 7. So this will be 2 times 49 minus 7, which gives us 91. Okay, so just to recap, if you're doing f composed of g of x, or no matter what the letters are, start with the first one and write it out with just parentheses wherever there's an x, every place there's an x. Then in that set of parentheses, plug in your second function, g, into those. Then you can simplify, and then if you want to evaluate at any values, you can.